Welcome you all in this video. In this video, we are going to discuss example on eigenvalues and eigenvectors of non-symmetric matrix. Here, eigenvalues are non-repeated form. Means the eigenvalues are non-repeated. Means they are different. They are not same. This is example. Here we are to find here the eigenvalues and corresponding to that eigenvector for the following matrix. So matrix has 3 by 3 matrix. So general characteristic equation for this matrix is lambda cube minus s1 lambda square plus s2 lambda minus determinant A equal to 0, where s1 is sum of these diagonal number. So add this 1 plus 2 minus 1 equal to plus 1 minus 1 cancel. We get here 2. Now this S2 is sum of minor of diagonal number. So this is diagonal number 1. So delete this row here, delete this row and this column. So remaining this 4 element 2, 1, 1 and minus 1. So write this in the form of determinant. So is here 2, 1, 1 and minus 1. Now plus second element, these two elements, this present in second column and this second row. So delete this row and this column. Remaining here this 1 and this minus 2, 0 and minus 1. So write this here 1, minus 2, 0 and minus 1. Now next, this last element, this minus 1. So delete this row and this column. So remaining 4 element, this 1, this plus 1, this minus 1, this plus 2. So write here 1, 1, then minus 1 and plus, then simplify this as to say S2 equal to S2 equal to cross multiply 2 into minus 1 is here minus 2. Then write here minus to multiply this 2. 1 into 1 is here 1. Then this plus. Then multiply this 1 into minus 1. So this minus 1. 1 into minus 1 is here minus 1. Then 0 into minus 2. Write here minus to multiply these two elements. 0 into minus 2 is here 0. Then this plus 1 into 2, multiply this 2. 1 into 2 is here 2. Then write here minus to multiply these two number. Minus 1 into plus 1 is here minus 1. Now simplify this. So equal to, you see, minus 2 minus 1 is here minus 3. Minus 3 minus 1 is here minus 4. Minus 4 plus 2 is here minus 2. Minus 2 and this minus minus plus 1 is here minus 1. So we get here minus 1. Again minus 2 minus 1 minus 3 minus 3 minus 1 minus 4 minus 1 plus 4 is minus 2 and this plus 1 is here minus 1. So we get here S2 equal to minus 1. Now find the determinant. The determinant of A, last, is determinant of A. So determinant of is we find here the determinant of this matrix. So equal to, write this matrix in the form of determinant as The first row numbers 1, 1, minus 2. Second row number minus 1, 2, and 1. Third row number 0, 1, minus 1, 0, 1, minus 1. Now find the determinant. How to find determinant here? So C equal to, so I'm taking a red color to denote this one to this. So right here 1. So here is 1, positive 1. So this is positive 1. Now remaining element. So which element here? So this 2, this 1, and this minus 1. So delete this column and this row. So write this 4 element determinant form: 2, 1, 1, minus 1. Now take second this plus 1. So here positive 1, write here negative. So negative 1 here. Now write this. Means delete this column and this row. So only element here minus 1, 1, 0, and minus 1, minus 1, 1. This minus 1, this plus 1, 0, and minus 1, 0, and this minus 1. Now next take plus here, positive, so is negative 2, so is here negative 2, and write the determinant for this minus 2. So delete this row and this column. So only remaining this minus 2 and this 2, this 0 and 1. So right here minus 1 plus 2, 0 and 1. Now find the determinant or solve this determinant. So determinant, so 2 into minus 1 is here, minus 2. Right here minus to multiply this number. 1 into 1 is here, 1. Then here minus 1. So minus 1 into minus 1 is here, plus 1. Right here minus to multiply this 0 into 1 is here, 0. Now this plus minus here, minus 2 in bracket. Now multiply minus 1 into plus 1 is here, minus 1. Now right here minus to multiply this two number. 0 into 2 is here, 0. Now do the calculation. So minus 2, minus 1, minus 3, minus 3, minus 1, minus 4. So is here minus 4. Now minus 2 into minus 1 is here, plus 2. So minus 4 plus 2 is minus 2. So therefore put this S1, S2 and determinant in this equation. So therefore lambda cube minus S1, S1 is 2, is a 2 lambda square, S2, S2 is here minus, so minus 1 lambda, then determinant A, determinant is minus, so minus minus here, plus 2 equal to 0 is characteristic, is characteristic equation of matrix A. Now solve this, means find the value of lambda here. Means we get here the eigenvalues of the given matrix. So this is cubic equation. So degree of this equation is here 3. So we will get here the 3 roots of this equation. So how to find? We can find this by using the synthetic division. So by using synthetic division, we first know the first root. How to find? By default. So put here lambda equals to 0, 1, 2, like this value. So put here lambda equal to 1. After putting lambda equals to 1, so we get here 1 cube is here 1 minus 1 square is 1. 1 into 2 is here 2. Then minus 1. Then plus 2. We are putting here lambda equal to 1. So 1 cube is here 1 1 square is 1, 1 into minus 2 is minus 2, 1 minus 1 plus 2. After adding this, we get 1 plus 2 is 3, minus 2 minus 1 is minus 3, plus 3 minus 3 is here 0. So we get here 0. So therefore, lambda equal to plus 1 is first root. First root. Now to find another 2 root of lambda, so use here synthetic division. So how to use the synthetic division? You see here. So vertical line take here, one horizontal line. So right here this lambda equal to 1 is here, lambda equal to 1 here. Now now write the coefficient of this lambda cube, lambda square, lambda and this 2. So lambda cube coefficient is here 1, then lambda square coefficient is here minus 2, then lambda coefficient is here minus 1, and this constant 2. Now do the operation. So see, write this 1 as it is here, then multiply this 2, 1 ones are 1, then minus 2 into plus 1 is here, minus 2 plus 1, add this 2. So minus 2 plus 1 is here minus 1, then minus 1 into 1, so is here minus 1, so minus 1 here minus 2. So vertically we add here and cross here, we will multiply here. Minus 2 into 1 is here minus 2. So plus 2 minus 2 here 0. So हमेशा याद रखो, we get here 0 always. Okay. Now write this 1 minus 1 and minus 1 in equation form. So how? So this is minus 2 constant. Multiply here lambda and multiply lambda square. 1 into lambda square is here lambda square. Then multiply here plus lambda. So here minus lambda, minus 1 into lambda. Then this constant as it is minus 2 equal to 0. So we get the equation from this synthetic division. So we call this by synthetic division. We have done this by synthetic division. So now find the roots of this quadratic equation. So how to find? We can find here by direct method. So see, lambda square coefficient is a 1, and this minus 2 multiply here. 1 into minus 2 is here minus 2. Now find the factor of this minus 2. As we add that 2 number, we get here this minus 1. So minus 2 into 1. So see, if we take a factor minus 2 into 1. So minus 2 into 1 is here minus 2. So we get here this minus 2. And addition of this minus 2 plus 1 equal to minus 1. So we get here this middle number minus 1. So factor of this is, we can write here lambda minus 2 and second is here plus 1. So lambda plus 1 equal to 0. So we get here the factor of this quadratic expression. Now find the roots of this lambda. So how to find? To separate it, lambda minus 2 equal to 0, and second is here this lambda plus 1 equal to 0. So we get here lambda equal to positive 2. So transfer this minus 2 here, we get here positive 2. Then lambda equal to, here is positive 1, take here, we get here negative. So lambda equal to minus 1. So therefore we get the value of lambda equal to first root. First root is here this 1, this 1. Second is here this minus 1, and third is here this 2 are eigenvalues. Eigenvalues of the matrix A. Now find the eigenvectors corresponding to these. So first of all, to find the eigenvalues, we know the homogeneous form of matrix. So see, so therefore we have homogeneous form of matrix as determinant of A minus lambda, not determinant, this is matrix, A minus lambda I into capital X equal to 0. So write the given matrix in the form of this. So directly we can write this here, say A minus lambda I. So we are subtracting this lambda I from this A. Means here see I is here identity matrix. So we can directly write this lambda in diagonally. Means we subtract that lambda from this 1, 2 and minus 1. So we write as here to see how to write this. To see n matrix. So first row 1, here is 1, so subtract by this lambda. So we get here 1 minus lambda, then second element 1 and minus 2 as it is, 1 and minus 2 as it is. In second row this minus 1 as it is, and here subtract by lambda to this 2 is here 2 minus lambda, and last element 1 as it is. In third row 0 and 1 as it is, 0 and 1 as it is. So last element is a diagonal number minus 1. So minus 1 minus lambda. So see here, lambda I. So I is your identity matrix. Okay. So minus 1 minus lambda. So we get this matrix. Here is capital X. So capital X is here unknown vector or unknown variable. Is here X, Y and Z. Take this equal to this O means a zero matrix. So write here column zero matrix 0 0 0. So this homogeneous form of system of equation in matrix form. Okay. Now find the eigenvectors. So how to find the eigenvectors? So see here eigenvectors. So these eigenvalues are different, not equal. 1 minus 1 and 2. So we will get here the eigenvectors also different corresponding to this eigenvalue. So eigenvector first, eigenvector corresponding to lambda equal to this positive 1. So take a positive 1. Now put this lambda equal to 1 in this homogeneous form of system of equation in matrix form. So lambda put here 1 minus 1 1 minus 2 as it is. Now minus 1, so 2 minus 1, then plus 1, then here 0 1 minus 1 minus 1, then here x y z equal to 0 0 0. 1 minus 1 is here 0 1 minus 2 minus 1, 2 minus 1 is 1 1 0 1 minus 1 is minus 2, then here x y z equal to 0 0 and 0. Now make the equation for this. So see, so this coefficient for x, so 0 into x 0x. Now plus for this coefficient for y, so y, this coefficient for z minus 2z equal to this 0. Now this minus 1 minus 1x, then plus y, then plus z equal to 0. Now next here 0x plus y minus 2z equal to 0. Now take these two equations. So write this equation in the form as this. We want to find here x, y and z value. So see how to find. So write this equation as means here x divided by. So here is x. So don't to use this x coefficient. So apart from this x and y, instead of this, to write the coefficient of this y and z in determinant form as, let's see, y coefficient is here 1 1, z coefficient is here -2 and 1 2 right here. Now equal to right here minus y. So don't take here the y coefficient, but take another coefficient, x and z coefficient. X coefficient is here 0 and -1. So right here 0 and -1. Another variable 2 -2 and 1. Right here -2 and 1. Close the determinant equal to last variable here z. So write the determinant of x and y here. So x coefficient is 0 and -1, 0 and -1, and +1 and +1. So +1 and +1. Now simplify this. Therefore, x divided by cross multiply 1 ones are 1. Right here minus to multiply these two numbers. 1 into -2 is here -2 equal to this minus y as it is divided by 0 into 1 is here 0. Then right here minus 2 multiply these two number -1 into -2 +2. Then equal to z divided by, then multiply these two first. 0 into 1 is here 0. Now take here minus to multiply these two number. -1 into +1 is here -1. Now simplify this. Therefore, x divided by here minus into minus plus 2 plus 1 is here +3 equal to is here minus y divided by 0 minus 2 is here -2 equal to j divided by minus minus here +1. So therefore we get here x by 3 equal to this minus plus here. So we get here y by 2 equal to j divided by 1. Now let one constant here x by 3 equal to y by 2 equal to z by 1 equal to k here. Now equate with this k. So therefore x by 3 equal to k. This implies that x equal to 3k. So transfer this 3 to here. So we get here 3k. Now second, y by 2 equal to k. Y by 2 equal to k. This implies that y equal to transfer this 2 here. So 2k. Now last z by 1 equal to k. Z by 1 equal to k. So this implies that z equal to 1k. So therefore, so we know that the vector x1. So this is x1 vector. Denote vector x1 equal to, so x, y, and z. We write in matrix form as, so equal to x. X is here 3k. Y is here 2k. And z is here k. Now take the common k from this. Take the common this k. So we get here k in bracket 3, 2, 1 is, this x1 is eigenvector. Eigenvector corresponding to lambda equal to now. Now find eigenvector corresponding to lambda equal to -1. Now put this lambda equal to -1 in this homogeneous form of system of equation in matrix form. So put lambda equal to -1 here. So we get a in matrix 1 -1, then second number as it is 1 and -2, second row -1, and here 2 -1, and here 1, last row 0, then 1, then here -1, -1, and here minus of -1 is closed. So right here unknown variable vector x, y, z equal to 0, 0, and here 0. Now simplify this. -1, -1, +1, +1, +1 is here, +2, 1, -2, then here -1, 2, -1, -1, +1, +3, here 1, then 0, 1, minus minus +1, +1, -1 is here, 0, then here x, y, z equal to 0, 0, 0. Now write these in the form of equations. So this is x coefficient, y coefficient, z coefficient equal to 0. So twice x plus y minus 2z equal to 0, minus x plus 3y plus z equal to 0, then 0x plus y plus 0z equal to 0. Now take these two equations. So write this in the form as x divided by, so write the y and z coefficient in the form of determinant as y coefficient is here 1 and 3, z coefficient is -2 and 1 equal to, in second term it is minus y divided by, so write the x and z coefficient in determinant form as x coefficient is here 2 and -1, z coefficient is here -2 and 1, then equal to z divided by, then write the x and y coefficient here. X coefficient is here 2 and -1, y coefficient is here 1 and 3. Now simplify this. So therefore x by 1 into 1 is 1, so write here minus, then 3 into -2 is here -6 equal to minus y divided by 2 into 1 is here 2, then write here minus, to multiply these two number, -1 into -2 is here +2 equal to z divided by 2 into 3 is 6, write here minus, then multiply these two number, -1 into +1 is here -1. Now simplify this. Therefore x by minus minus plus 6 plus 1 is here 7, so then equal to minus y divided by 2 minus 2 is here 0, then equal to z divided by minus minus plus 1 plus 6 here 7. Now divide the 7 throughout the equation, so we get here x by, so 7 by 7 is here 1, then -1 it goes to here, so 0 into minus here 0, so y divided by here 0, then equal to z divided by, if we divide the 7 by 7 we get here 1. Now let x by 1, y by 0 and z by 1 equal to k. Now equate with k all these three, x, y, z. So first x by 1 equal to k. This implies that x equal to k and y by 0 equal to k. So this implies that y equal to 0. If you multiply here 0 into k is here 0. Then z by 1 equal to k. This implies that z equal to k. So therefore x2 vector we write as x, y and z. So this equal to x is here k, y is here 0 and z is here k. So we get, take the k common here, so we get here 1 0 1 is the eigenvector corresponding to lambda equal to -1. Now find eigenvector corresponding to lambda equal to 2. See, we got here 3 eigenvalues, 1 minus 1. Now find the eigenvector corresponding to this 2. So 2. So write the matrix or put this lambda equal to 2 in this system. There is 1 minus 2, 1 minus 2, then 1 minus 2. Now second row, minus 1, 2 minus 2, so 2 minus 2 and 1 here. Now last 0 1 0 1 minus 1, we are putting here lambda equal to this 2. Then x, y, z equal to here 0 0 and 0. Now simplify this. So we get in matrix 1 minus 2 is minus 1. So is a 1 and minus 2, 1 and minus 2. In second row, minus 1, minus 1, 0 here. 2 minus 2 is 0 and this 1. In third row, 0, 1, minus 1, minus 2 is minus 3, 0, 1, minus 3. Second matrix is there, unknown variable matrix x, y, z equal to here 0, 0 and 0. Now make the equations for this. So is here minus x, for this plus y minus 2z equal to this 0. Make the second equation from the second row, minus x plus 0y plus z equal to here 0. From third row, 0x, this is for y, so y, this is for z, minus 3z equal to 0. So take these two equations to find x, y, z. So write these two equations in the form of as, so x divided by, so write the coefficient of this y and z here. Y coefficient is 1 and 0, z coefficient is minus 2 and 1, equal to right here minus y divided by, now write the x coefficient and z coefficient. X coefficient is minus 1, minus 1, minus 1, minus 1. Z coefficient is minus 2 and 1, minus 2 and 1 here, equal to z divided by, now write the coefficient of x and y here. So x coefficient is minus 1, minus 1, minus 1, minus 1. J y coefficient is 1 and 0, 1 and 0. Now solve this determinant. So x divided by, first multiply these two numbers. 1 into 1 is 1. Right here minus, to multiply these two numbers. 0 into minus 2 is 0. Then equal to here minus y divided by. So minus 1 into plus 1 is minus 1. So right here minus, to multiply these two numbers. But you do both numbers are here negative. So minus 1 into minus 2 is here. Minus 1 into minus 2 is here plus 2. Equal to z divided by, then multiply these two. Minus 1 into 0 is 0. So right here minus, to multiply these two numbers. Minus 1 into plus 1 is here minus 1. Now simplify this. X divided by 1 minus 0 is 1, equal to minus y divided by minus 1 minus 2 minus 3. Then equal to z divided by minus 1 is here plus 1. So therefore x by 1 equal to this minus plus, we get here y by 3 equal to z by 1. So let x by 1 equal to y by 3 equal to z by 1 equal to k. Now x by 1 equal to k, equate this with k. So this implies that, transfer this one in here k, so 1 into k is k. So x equal to k. Now for this y by 3 equal to k. Now this implies that y equal to 3k. Now last, z by 1 equal to k. So z by 1 equal to k. This implies that z equal to k. So therefore x3, third vector. The third vector we can write here x, y, z. So we know the value of x. X is here k. So write here k. Y is here 3k. So write here 3k. And z is here k. So write here k. And take the common k here. So we get here. There is 1. Here 3. And here 1. So 1, 3, 1 is eigenvector corresponding to lambda equal to 2. So these are three eigenvectors, x1, x2, x3, corresponding to given eigenvalues for the given matrix. Thank you.